Welcome to Math, where problems are no problem. Say you're building a square patio, and one side measures 5 feet. How many square tiles do you need? You multiply the side by itself, 5 times 5. That single move, multiplying a number by itself, is the whole idea behind exponents. And figuring it out is either a fun weekend project or a minor life crisis, depending on how you feel about math. Later, if someone hands you a finished patio and asks what side length gives you a certain number of tiles, you're running that same idea backwards. That's called a root. Same patio, opposite direction. Let's nail the vocabulary first, since ASVAB questions test the words just as much as the arithmetic. When you multiply a number by itself, writing 5 times 5 every single time gets tedious fast, especially with bigger repeats. Imagine having to write out 10 copies of a number multiplied together every time you needed it. So there's a shorthand. Write the number being repeated. That's called the base. Then a small number floating above it that tells you how many times to multiply that base by itself. That small floating number is the exponent. 5 with a small 2 above it means 5 times 5. 5 with a small 3 above it means 5 times 5. In plain terms, the exponent just counts copies. See a 2 up top, multiply 2 copies of the base together. See a 3 up top, multiply 3 copies together. Back to the patio. Side length 5 feet, area written as 5 squared. Let's actually walk through it. 5 squared means 5 times 5. That's 5 groups of 5. Or think of it as addition in disguise. 5 plus 5 plus 5 plus 5 plus 5. And either way, you land on 25. 5 squared equals 25. So you need 25 tiles. And squared isn't some mystical math word. It's called that because it's literally the area of a square. Now flip it. Someone tells you the patio used 25 tiles arranged in a perfect square and asks for the side length. You're asking, what number, multiplied by itself, gives 25? That question has its own name, a square root. It's written with a checkmark-shaped symbol called a radical placed over the number. The square root of 25 is 5, because 5 times 5 gets you back to 25. In plain English, squaring means multiply the number by itself. And a square root means find the number that, once multiplied by itself, gives you this. A quick side note, not every number has a nice whole number square root. The square root of 10, for instance, isn't a whole number at all. 25 was a friendly choice here because it's what's called a perfect square, a number that comes from squaring a whole number in the first place. If a question ever asks for a cube root instead, the idea is identical. Just one more factor of the base multiplied in. This relationship shows up all over the ASVAB math knowledge section. Anytime a problem hands you an area or a total and asks for a side length, or hands you a length and asks for an area, you're using exponents and roots as two directions of the same operation. You'll also run into it in questions dressed up with physics language, like force or speed, wherever squared units show up. One trap worth naming. Squaring a number is not the same as doubling it. 5 squared is not 5 times 2. It's 5 multiplied by itself. 5 squared, not 5 doubled. It's a mistake that costs easy points, because the test isn't asking you to double anything. It's asking how many times the number multiplies against itself. Keep those separate, and you'll dodge a classic test A trap. Let's check both directions on our patio numbers. 5 squared is 5 times 5, which is 25. That holds up. And the square root of 25 is 5, since 5 times 5 lands right back on 25. Same fact, just read backwards, so that checks out too. In plain language, squaring 5 and then taking the square root just walks you there and back on the exact same path. So here's the one thing to carry with you. An exponent tells you how many times to multiply a number by itself, and a root asks that same question backwards. What number, multiplied by itself that many times, gets you here? Exponents build up. Roots take you back down. Same patio, opposite direction. If this helped, the next video covers scientific notation. And if this channel's helping you make sense of this stuff, subscribing helps more people find it too.